Hello everyone, welcome back to our class Engineering Mechanics session 2. So, in this session I am going to explain about the resolution of forces. So, what is meant by resolution of forces? So, resolution of forces is nothing but in the last class we learned about the different types of force systems and classification of the different forces. So, we learned about that different types of force systems. Now, in this class I want to resolve the force in between the whenever the two forces or two or more forces acting from the same point from the same plane. Okay. So, for this today I am going to explain one important topic. So, that is the parallelogram law. So, parallelogram law is one of the most important topic in engineering mechanics. So, this is mainly used to resolve the forces in between from the same point whenever the forces are acting from the same point into different directions. Okay. So, here this is the law, parallelogram law, which states that resolution of forces. So, here I am taking the point O, this is the body, let us take a body. Here from the point O, one force which is having the magnitude P, which is going into the x direction, and one more force I am introducing, this is the Q, which is having the magnitude Q. So, in the inclined y direction. So, these are the two forces are acting from the same point. So, that means here this is the concurrent force. Now, I want to know the resultant in between the two forces P and as well as the Q. Okay. So, how I will know the resultant? So, here I want to introduce the one more resultant. In the last class we learned about equilibrium of a body, equilibrant and resultant, right. So, based on that point here I am introducing the one more resolution of the forces. So, the angle between the two forces is let us assume theta. Okay. So, here I am introducing the one more force that will be treated as this is the magnitude and direction of the resultant. So, now I want to know the exact resultant in between the two forces. So, it is mainly defined as this parallelogram law mainly states that whenever the two forces are acting from the point O, okay, in the direction of A and in the direction of B, let us take A and B. So, with the magnitude and direction, P and Q is the magnitude, A and B is the direction. So, these are acting based on the parallelogram law adjacent sides. Now, one more force I am introducing, that is the force R, which is acting as a diagonal of the parallelogram to resolve the forces between the P and Q. So, let us take this is the point from the point O, here O to A. So, this is the force with magnitude P and this is the with magnitude Q, let us take B. Now, draw the one more diagonal, introduce the diagonal. So, this is the join point C and so this is the representation of the parallelogram law. So, here these are the two forces which are acting with the inclination theta. One is having the magnitude P, another one is having the magnitude Q, which are going into the directions A and B. Now, based on the adjacent sides of the parallelogram, one more force I have introduced, that is with the magnitude R. This is the resultant. Here I am going to find out the resultant in between the two forces P and Q. So, let us take the diagonal line of the parallelogram law which is having the magnitude and direction. Now, join the lines BC and as well as the CA. A parallelogram law is formed. So, which will gives the resultant between the two forces P and Q. Okay. Now, I want to know the resultant, right. So, for that I want to extend the line CA up to point D. Now, here you can assume that OB which is parallel to here CA, right. Therefore, we can write it as directly OB equals to CA equals to, we can directly take the value Q. And here up to O to A we know that the value is P. Now, I do not know the values of AD and CD, right. So, from this law we can state that from this triangle directly OCD. So, here you can see, you can identify this is the triangle OCD, right. So, here or else we can take the triangle OAC. Okay. So, directly I want to write from the triangle C. Okay. So, this is OAC. What we can write? So, I want the resultant, right? So, this is the triangle OC square. So, OC square equals to, again I can write sorry, here we will assume the triangle OCD. Okay. So, that means OCD. So, here from this triangle, so here I can write what I can write, OD square plus here CD square, right. So, from this value OC is nothing but R, directly we can find the resultant R. Now, what is mean by OD? So, here OD. So, OD how we can write? OD equals to, here I want to write OA plus AD. Okay. So, I do not know the value of AD and as well as the CD, right. So, in order to represent the AD and CD values, take the triangle. So, from this triangle I want to represent the values of AD and CD. Okay. So, here ADC, this is the triangle. So, how can I write? So, from this triangle AD equals to, so I can write AC into, this is the horizontal line, right. So, I will take the representation sin theta. Similarly, here I want to know the value of CD. So, therefore, CD equals to, I will take AC, okay, this is the adjacent side. So, AC into, I will take the vertical direction as the cos theta. So, here we know the values of AC. AC is nothing but, here OB is parallel to CA, then directly we can take the value of Q, right. So, here I am substituting the values, therefore, directly here we will get the Q sin theta and directly here we get the Q cos theta, right. So, from this representation I want to substitute these values in this equation 1. Let us take this is the equation 1. Okay. So, here OC is nothing but what we are going to find out here, this is, here we are going to identify the resultant, right. So, here this is the resultant R. So, substitute R square, that is equals to here OD square. So, OD square is nothing but again OA plus AD whole square, that plus CD square. So, here I want only R value. So, R under root of what will taken? OA. So, let us substitute the values, right. So, what is mean by OA here? OA equals to OA. So, here it is showing up to O to A, it is showing the value P, right. So, substitute P plus what is the value of AD? Here we have taken the from this triangle, right. CAD. Okay. So, from this triangle we have taken, so the value of AD. So, AD equals to Q sin theta plus, okay. So, this is Q cos theta. So, from this values we can take R equals to under root of, this is in the form of A plus B whole square, right. So, P square plus Q square plus 2PQ, sorry, just a small information here, this is the value of CD and this is the value of AD. Okay. So, then here we have to substitute cos. So, 2PQ cos square theta plus Q square sin. So, Q square sin square theta. So, from this here we can represent, that is cos square theta plus Q square cos square theta. Okay. So, here directly we can take R equals to, let us write here. So, R equals to, here I will take under root of P square plus Q square cos square theta sin square theta. Let us take common cos square theta plus sin square theta plus 2PQ cos theta. So, 2PQ cos theta. Therefore, R equals to, what is the value of cos square theta plus sin square theta in trigonometry? Let us take the value of cos square theta and sin square theta is the 1. Okay. So, therefore, so let us common this value. So, this is the 1. So, therefore, P square plus Q square plus 2PQ cos theta. So, this is the value of resultant R. finish with